And welcome back, grade 7. In this video, we're going to get into, again, perimeter and area, but of a bit more of a complex shape. And that shape is a circle. And we're going to learn very quickly that when we talk about circles, we don't use the word perimeter. Instead, we use a special word for it called circumference. Before we talk about that, though, let's understand a couple of different terms involved with a circle. So if I were to draw a circle here, the distance around the outside is called the circumference. So that's the distance all the way around, or what we normally talk about as being perimeter in a shape like a square, rectangle, or a triangle. The distance all the way across the circle here, we call that the diameter. And if I'm just going halfway across, we call that the radius. And then, of course, we also have the center of the circle as well. These are going to be the main words or terms that we're going to use as we step through understanding a little bit more of how to figure out these different formulas. So first of all, let's just deal with diameter and radius. So you'll notice here, if diameter is all the way across and radius is halfway across, then our first formula is that diameter equals 2 times the radius. Or if you needed to work backwards from that, you could also say that radius equals 1/2 of the diameter. So you could use the both things here. Radius equals diameter divided by 2 in order to figure out one or the other. We are going to be using those in a bit to figure out things like circumference and to figure out things like area. So circumference and diameter, they're really kind of interesting things this way. When we're talking about a circle, we actually need to use a very special unit in math. And the special unit in math is called pi. And chances are you've heard of it before. It's a very famous math term, something that's used quite a bit here. And although you might not see it written this way very often, sometimes you might see it written this way. And that is the universal symbol for pi, which we use when we're solving things within a circle. And simply put, pi is not a number that we can write. It is actually a never-ending decimal. Even the most powerful computers have tried to find an end to it and haven't yet. Pi is basically the circumference of any circle divided by the diameter. And it always, no matter what circle we're dealing with, no matter how large or how small, it always comes out with this exact same number. And that number is roughly equal to 3.14. Technically, it goes like 3.14159265358 and it keeps going over and over and over and over again. And there have been people who have sat there and who have memorized a certain amount of digits of pi. But for what we're working with, we're going to work with 3.14, or if you're doing calculations on your calculator, some calculators might also have a pi button that you might use as well. So in order to figure out the circumference of a circle, we're going to use that new pi symbol in a bit of a formula. So circumference, remember that circumference is our big fancy term for perimeter, just dealing with a circle, is going to be equal to pi, that special number that we figured out, times the diameter, pi d. Sometimes people might write this as 2 pi r as well. They're the same thing. Remember that 2 times r, or 2 times radius, is going to be the same thing as the diameter anyways. So we're saying the same thing here to figure out the circumference or the distance around the circle. To figure out the area of a circle, we use a formula of pi r squared. Pi times radius squared. Now the key thing to remember here, and we'll practice this in a little bit, is that when we are working through this particular formula, remember, order of operations, that we do our exponents before we do our multiplying. So you have to do r squared first, and then you can times that by pi in order to get an accurate value for our area of a circle. These are the formulas that we're going to be using. By all means, don't feel like you need to have them memorized. Write them down somewhere that you'll be able to see and you'll be able to refer back to from time to time. As we go through the rest of this unit, it's not a bad idea for you to start collecting some of these formulas on a sheet of paper so that you can refer back to them as you're dealing with many of these different types of shapes. That's the end of our lesson for today, although next we're going to be stepping into our examples. If you'd like to stick around and hear some of those examples, feel free. Otherwise, you can take a look at the pictures and go through. Just remember that the triads mirror the examples, so if you get stuck, it's not a bad idea to come back and to try to figure that out, or try to look at the examples to figure out the triads. All right, let's take a look. We have a number of examples that we're going to be going through, two main examples here, dealing with diameter, circumference, as well as area. So first, we have example 3. And in example 3, we're told that the diameter of a circle, so we have a circle, and the diameter, that's the distance across, is 14 centimeters. Okay. Then it asks, find its circumference and area in a number of different ways. It first asks us to figure out the circumference and area using pi as 3.14, that rounded number that we had. So to figure out circumference, remember that circumference equals pi d. So circumference equals 3.14, that's what pi is, times d, which is the diameter, which we were just told is 14 centimeters. When you plug that into your calculator, you'll see that this will give you a circumference of 43.96 centimeters. Remember that just like perimeter, we just have centimeters, not centimeters squared. Perimeter is just the unit, and area is the unit squared. For the area is pi r squared. Now I don't have r yet, I just have diameter, but remember that radius is just half of that. So half of 14 centimeters would mean that it has a radius of 7 centimeters here. So for the area here, it's going to be 3.14 times 7 centimeters, and that 7 is going to be squared. So we have to do the squared first. So 3.14 times 49 centimeters squared. Notice how here my squared sign switched. It was at the number, so I had to square the number here. But then here, now it's just on the centimeters, because it's just centimeters times centimeters. This doesn't affect the number anymore. It just means that I have two sets of centimeters multiplied together. When I multiply these two terms, I'm going to end up with a value of about 153.86 centimeters squared. So that's what would happen if we used pi as 3.14. The next one asks us to use pi, or figure out using pi as a fraction. And so pi as a bit of a fraction, let's do part B here, would be pi equals about 22 over 7. So to figure out perimeter or circumference here is going to be 22 over 7 times 14 centimeters, which I would multiply the two across the top, then divide by 7. That would give me a circumference of 44 centimeters. So you'll see how they're fairly close, but depending on what we use for pi, we might have slightly different answers. 43.96 and 44 are slightly different here. For the area equals 22 over 7 pi times radius, 7 squared centimeters. So we already know 7 squared centimeters is 49 centimeters squared, times this, so 22 times 49, then divide that by 7. is going to give us an area of 154 centimeters squared. So once again, very close, but not exact answers, depending on what method we use. If you were to use your calculator to figure that out, now some calculators round pi to much higher values, you're going to get a much more accurate result. And let's see what that might look like. So if you were to just on your calculator do the pi button times 14 for the circumference, at least on my calculator, I end up with something like 43.98. Now I rounded that. It technically keeps going on my calculator, but I rounded that. You'll see as well, it falls kind of in between the 3.14 and the 22/7. So we're in the similar ballpark here. For the area, we have pi times 7 squared, or in other words, pi times 49, which gives me an area of 153.94. Again, that's rounded to 2 decimal places, centimeters squared. Again, close to this, close to this. We're in the same ballpark. You'll notice how whether we use pi as 3.14, 22/7, or just pi on our calculator, we get very similar results, although they might be off by a couple decimal places as we seek to get more and more accurate. For the questions that we're going to be working through, you can use either methods for pi in solving this. When you're going through the answers, choose the one that fits most closely to the answer that you got, even if it might be a couple of decimal places off because of the different methods that could potentially be used. So that's example 3, just taking a look at the different versions of pi. Let's take a look at example 4 and get into some more practical applications with this. Example 4 says the circumference of a circle, so here's our circle, the circumference, the area around, is 6 pi, which is interesting. It's giving us the circumference as pi already. And we're having to work backwards now to figure out, in this case, the radius. So remember, this is the diameter, this is the radius, so this is the diameter, this is the radius. We're having to figure out that. In other words, we have to work a little bit backwards here. So remember that circumference equals pi d, or what's maybe more applicable for us, circumference equals 2 pi r. Made a little mistake there. 2 pi r. So I know the circumference and I know pi. So I know the circumference is 6 pi times 2 pi r. I just need to figure out r. So in order to figure out r here, to get r by itself, I have to divide out the rest. Divide by 2 pi. Divide by 2 pi. Now these cancel out. 6 pi divided by 2 pi, pi's and pi's cancel each other out, 6 divided by 2 equals 3. I'm able to figure out that this circle has a radius of 3. That's part A. Part B, so this is part A. Part B then says the area, figure out the area of the circle, leaving your answer in terms of pi. So we don't have to solve it beyond that. Our area equals pi r squared. So it says we can leave it in terms of pi, which means that we can leave our pi as a part of the question. We know what our radius is. Our radius is 3 now, so pi 3 squared. 3 squared is just 9, so pi 9, or 9 pi. We can switch these around however we want. We don't have to go beyond that because it asks us to keep it in terms of pi, so there would be our answer. Most likely we'd have our number first, so 9 pi centimeters squared. Would be our area of this particular circle. The last part of this question then says the radius of a circle whose area is half that of the given circle. Okay, so this one gets even trickier yet. We have to figure out what the radius is going to be given this particular area. So, and given this particular area when it's kind of cut in half as well. So, first of all, this area cut in half is going to be about 4.5 pi. That's going to be our area now. And now using that area, we need to figure out what the radius is going to be. So remember that area equals pi r squared. So now our area is 4.5, pi is still just pi, and r squared, we still have to figure that out as well. Our first thing here would be to try to get r by itself. We divide pi. Get that out of there. Divide by pi. The pi's cancel out. The pi's cancel out. And I'm now left off with 4.5 equals r squared. Now this gets back to our algebra. To get r by itself, it's r squared right now. The opposite of r squared is our square root. And so we take the square root here. On your calculator, you have a little square root button. Looks a little bit like that. The square root of 4.5, it's going to give you a long decimal. It just asks to round it to the nearest 2 decimal places, which would be about 2.12. So in this case, you'll notice that when we half the area of a circle, we don't necessarily half the radius. We went from 3 to 2.12. And so we do have to figure that out separately when we go through these types of calculations. But this would be how you would step through. This is part C now, that particular example and that particular try it question that matches it as well.